Okay, so this is the final class today, and I'm trying to show some exercise, and then you will know how important of the unit conversions. Okay, so this is another exercise, and first we should understand what are the questions and what is the answer we require to provide the answer. And so the first, this is example show calculations of the powers. So the most important thing, the first, you need to know what is the power. And the power required to ride a bicycle at the speed of the v is equal to the 20 mph. So the second question is, what is the mph? Even though we know that this is the physical property is velocity, but we can see the sentence use the mph. So we need to know the first, what's the unit for the mph. And when the force to move against the wind drag is the force F is equal to the 4-pound force. And we need to answer the question is the power. So for me, first I will understand the power first. So usually the power is indicate the unit is the joule per second. And the joule per second, sometimes we will use the W is the watts. So let's indicate we say the power is the gong. So we need to know how many joule per second is the power. Okay, and we know that the P can be defined by the F multiply the velocity. The F multiply the velocity. So the questions already provide me the two variables is the velocity and the force. But we should try to convert the unit first before our calculation. Because the joule per second in here is the SI unit. But what we have right now, this is the imperial unit, and mph is not the SI unit. So we should convert the unit first. And sometimes we call that we should fix the unit consistent. Okay, and then we can looking for the questions. Okay, so the first I'm trying to convert. The first one is the velocity. So I know the velocity in here v is the 20 mph. So the first we should interpret the mph the meaning here. So the 20 mile per hour. Okay, so our purpose is to convert the 20 miles per hour to be the meter per second. So this is our first purpose. So, and I highlight some conversions here. I know the 1 mile is equal to the 1.609 kilometer. So here I first will multiply the 1.609 kilometer and per hour, right? This is sometimes we call that the 时速. Okay, so we can use the calculator compute the answer first. And this is will equal to 32.18 kilometer per hour. Okay, but this is not our terminate purpose, because our terminate is the meter per second. So we should convert the kilometer to meter. So we multiply the 1,000 to convert it to the meter unit. And I know the 1 hours has the 36,000 seconds. So in here, I should divide the 36,000 seconds, okay? And then you use the calculator to calculate the meter per second velocity numbers, okay? So multiply 1,000 for the velocity per hours, and divided the 1 hour seconds. And this will equal to around 8.94 meter per second. Okay, so I keep these numbers. The seconds, because the force is equal to the 4-pound force. And our purpose is to convert the pound force to newtons. And if we remember, 1 pound force will equal to the 4.448 newton, right? So we should convert the pound force to newton in here. So I multiply the 4.448, and the unit will be the newtons. And I use the calculator to compute the true answer. It's around 17.79 newton. And then we already have the force and velocity in SI units. So I can directly compute the powers, okay? So the final purpose is to compute the power with the force and the velocity. So I put the two number together is 17.79 newton, and multiply the 8.94 meter per second. Okay, so I use the calculator to compute the final answer. It's around the 159, and the unit is newton multiply the meter per second. And as we know, the newton multiplied the meters is equal to the joule. Okay, so we can rewrite the unit is equal to the 159 joule per second. And I have emphasized the joule per second. We sometimes call that the W watts. Okay, so this is the 159 watts for our problems. So the questions I don't use to remember everything. I just wondering you try do the unit conversions by yourself. So the government equations, the idea for the power, I already write down to here. So for your side, you only need to conversion the unit to be the SI and then multiply two numbers together, and then you can calculate how large power we have. Okay, some knowledge is quite simple because we know that the 1 joule will equal to the 0.002388 calorie. And I try to do some exercise. If I ride the bike with the velocity is around 32 kilometers per hour, and I try to ride the bicycle 1 hour, and I will have consuming calorie is around 100. But when I double check the 养乐多 the calorie is almost around 1/2 养乐多 calorie. So this is makes sense because even though we ride the bicycle 1 hour, but our body fat still look very fat because after that we drink some milk tea and like too much sugars in milk tea. So even though you may ride the bicycle over than 5 hours, and then you can cancel out the some body fat, right? Okay, so that's very good exercise. Sometimes we write, we calculate some answers, but we should make sense in our life. We can double check. That some people argue that why I always do exercise, but I still look a little fat, right? But you will calculate theoretically how many calories you consume means. You will understand the reason. Okay, so for our class is also sometimes we calculate the answer and I will review the answer, and in my life how can I interpret these numbers in my life? OK， 这个我觉得很重要，就是我们其实我觉得最难的就是我们在做力学的时候，其实我们算出来以后往往都不知道这到底是什么意思。然后这个很重要吗？那这个数字是对的吗？那合不合理？其实你想一下，你就会觉得蛮合理的。因为其实时速骑30公里，然后我骑1个小时，每小时30公里骑1个小时很累哦。如果大家试着骑看，所以这样子也才消耗100多个卡路里。那我今天到底要运动到怎么样的程度才有办法保持我的身材？这真的是一个很难的问题。所以这样子我想起来也会觉得蛮合理，所以我没有算错。有些时候其实我们没有答案，所以我不知道我有没有算错，这很合理啊。可是我会去检查我这个答案合不合理。这个是我觉得未来大家在修很多课程的时候，你算出那个数字，你想一下它对不对，你就想一下它合不合理。Okay, so we still have some exercise, and this is a slide just summarize some important unit conversion. So again, first we convert the Bohm force to Newton, okay? And the second, we convert the mph to the meter per second. And finally, we can directly compute the power by force and velocity. And we know that the Joule per second is correlated to the watts. So this is our final answer. Okay, so nothing difficult. Only one difficult in here. If you don't know, one Bohm force is equal to how many newtons, and you cannot find the final solutions. Okay, so you should keep the very important unit conversion in your mind. And then, so the table, okay, repeatedly occurred. And I just final push the table list in here. So I remind you, we have the length, mass, time, force, pressure, density, volume, and the power. In our following class, there are our primary units will be used in our problems. And then we know that we can do exercise. So first we know that 1 ft will equal to 0.3048 meter, right? And I know the one Bohm mass will equal to the 0.4535 kilogram, and I know the one slug will equal to the 32.17 Bohm mass. So that's an important unit conversions for the mass. And then we know that the time is a consistent unit, even though different, even though you use the different unit systems. And then the force and the Bohm force. So we know that one Bohm force will equal to the 4.448 Newton. Okay, and what's the pressure? Pressure, the Pa is the Pascal here. But we know that the pressure unit should be the Newton per meter square, right? The Newton per meter square. But at the right hand side, you didn't see, I think you didn't see the unit PSF before. So what's the meaning for the PSF? PSF is the Bohm force and per ft square. That's why we call that is the PSF. So similar, if I write down the pressure unit is the PSI, what the PSI means is the Bohm force per inch square. Okay, so that the SI system or the English unit systems, they are different pressure. In the SI system, usually we use the Pascal and the pi. But for the English units, usually we use the PSF or PSI. So the difference. Okay, and the density we didn't worry. I'm not worried for the density because I know the density is a kg per meter cubic. And here I will use the slug per ft cubic. Also, that's a difference. And the volume use the meter cubic, but here use the ft cubic. And the watts here, but we can change it to the ft bound force per second. Okay, so that's the in this class we have many slides. Just always emphasize repeatedly how important of the unit conversions. So for you, when you go home, you may write down some important numbers on your side, and repeatedly see the number again, and finally you will remember. Okay, and then some symbol will use in the future. That's I emphasize that for the length here I will use the capital L, and the mass here I will use the capital M, and the time use the capital T, and the temperature we will use the theta, and the amount of the matter we will use the number. It's N is related to the mole. Okay, so this is the symbol in this textbook. So if you in our chapter 8, the topic related to the dimensional analysis, you should use the symbol to do some exercise. So in the chapter 8, I will repeatedly emphasize some importance before the chapter 8. Okay, but that's some important thing is the some parameter there is no dimensional. Okay, as the one parameter I showing here, we call that the Reynolds numbers. And why there is no dimensional, you can double check based on the dimensional balance. You see, if I define the Reynolds number, the V here, V is the flow velocity. So I already know this is the velocity. So I know that the dimensional is the L divided the T, right? L is the length and the T is the time because this is the velocity. Okay? And the D in here, what's the D? D is the diameters of the pipe. That indicates the flow in the pipe. And the D is the diameter of the pipe. So we know that is the diameter of the pipe. So you can see what's the dimensional. The dimension is the L, right? Because the diameter is the length. Okay? And we already know the rho is the density, right? So the density, we have the mass divided the volume. So the volume is the length cubic power. Okay? So only one parameter you didn't know right now is the mu. The mu here is the viscosity. Okay? The mu here is the viscosity. And in the chapter 2, I will teach you more details about the viscosity. But right now you didn't know what is viscosity definitions. So I directly tell you the dimensional here is the M divided the L and the T. So if you put all of the dimensions, go back to the equations for the Reynolds number here, and you can cancel out all the parameters or the dimensional here. So that's a number we call that the dimensionless. Dimensionless number. That's no any dimensional inside the parameters. Okay. So and the nano number is very famous parameters is widely used for describe the flow conditions. That means if the nano number increase, and in case the flow velocity may be also increase, right? So that means the large nano number, the flow condition is quite dynamic, strong dynamic. Okay. So in the future, I will teach you what the certain definition of the nano number and how can we apply it to our real case. Okay, so this slide just emphasizes some parameter there is no dimensional. So you don't need to do some conversion, right? Because the parameter no dimensional, so you don't need to consider their units. Okay, and sometimes we will do some dimensional balance, or we call that the dimensional homogeneity. As you can see, we know that the equation is the pressure. This is the pressures, and this is the density. This is specific gas constants, and this is the absolute temperature. So we can put the dimension each side, and try to make the balance on the right-hand side to compare to left-hand side. If they are consistent, that means your balance is correct, or your unit conversion is correct. Sometimes I will use the dimensional homogeneity to check my answers is correct or not. If you compute all the parameters you already know on the right-hand side, and the final answer, the unit is not consistent with the left-hand side, that means something wrong here, right? So you should go back to double check what is the wrong positions, and you should make the corrections. Okay, so usually we will call that is DH. That means we always do dimensional homogeneities for our questions. Okay, and my slide sometimes will have the star on the right-hand side. That means if you cannot understand what I mean, but at least you should remember some keywords in here. Some keywords right down in here. Okay, so in my style, all the slide, if you can see some star on the slide, and you should remember some sentence, very important. Okay, so it's almost our final two exercise, and I'm trying to explain how can we build a mass model. Okay, how can we build a mass model? Okay, so this is a rocket. This is a rocket. And then when we see the movies for the rocket, okay, so you see this is a rocket, and when the engineering design a rocket, we should consider too many conditions, and the complicated systems is very difficult to design, because sometimes we push the rocket on airspace, and we want to go outside and consistent rotate around the Earth. So it's very difficult to design, and if we see the problem, and then we go back to see the system described in the slide. So this is our rocket, and this is our physical systems. And the important thing in here, we're trying to build out the mass model. So how many mass model we will use in rocket problems, rocket system? So I show 3 equations here. You only understand what is the ideal gas law, right? But another 2 equations you didn't know. For example, you didn't know the momentum equation. What is the momentum equation? And you didn't know what is the drag equations. Okay, so for me, how can we apply the ideal gas law? Because in the system, the gas is involved. So where is the gas? If you see the movie, you know that there is the gas. There are some gas. Okay, just is sourced outside and provide the push force to the rocket. Okay, so we have the gas and will is sourced in here and create the push out force for the rocket. So in that way, because we have the gas material involved in our system, that's why how can we build the mass model? So I know that here I can use the ideal gas law for this problem. And when the rocket going up, and there are some drag force. The drag force is the resistance force. Okay, that means the drag force will push down the rocket. Because we need to take the drag force into account. So what are the equation we need? So we need the drag equations to compute how large drag force we have, right? So when we consider the systems and we need some mass model to support our ideas. Okay, so right now we don't know what is the momentum equations. And what is our final purpose? Our final purpose is to provide the useful predictions. So how the useful prediction we need? We need to predict the speed of the rocket, and we need to predict the maximum altitude of the rocket. Because if we predict the maximum altitude is quite slower, the rocket cannot go outside the airspace, right? So we should compute all of the models and how can we predict the high enough altitude for the rocket and what are the speed we need. Okay, so this is sometimes we should build the mass model, but we still didn't know what is the momentum equations. What is the momentum equation here? So the next slide just summarize what is the momentum equation. So we make the force, the left-hand side, this is the force. This is a force diagram. And the right-hand side is the momentum. We know the momentum is the mass multiplied the velocity. And then we know the force is simply just the force. So we make the force balance will equal to the momentum rate. This is the momentum equation. The left-hand side is external force. Sum of the total external force will equal to the right-hand side is the momentum rate. We call that the momentum equation. And I will teach you in chapter 6. So right now you didn't know what the details for the momentum equation is, no matter. Because I already tell you this is the sum of the external force. Okay? This is related to the left-hand side, the force diagram, will equal to the momentum rate. This is the momentum equation. OK， 动量随着时间变化量会等于外力的总和。如果你不知道这件事情为什么会成立，你可以去做一下 unit 的平衡，因为你知道 momentum 是质量乘上速度，但是我是 momentum rate， 所以是还有除上一个时间，随着时间的动量变化量会等于作用力的总和。那力的单位你也知道，那势必这两个单位是不是要一致？那它才会成立等号嘛。Okay, so you can go back home and double check the unit consistency for the external force will equal to the momentum rate changed. Okay, but the more details I will discuss in the chapter 6. And on the slide, I highlight some important skill when you meet the problem. You just step by step follow the sentence I show in here. So the first, what you need to do, you need to do the problem statement, because you need to know how the problem you have. And you should define the situation. So you should find out how many physical property you already know, and what you didn't know, and what's the assumption you should satisfy. And then you can go to the next step. Okay? After you check everything is well, and you can set your goal. That means what are the unknown parameters you should answer. So you should set the goal, and you should make a plan, like what kind of the equation you will apply, and what's the math model you will apply in your questions. And then you do it, and finally you find your solutions and review the solutions to the problem. So what the meaning, the review the solution to the problem? That's similar to our previous exercise. I calculate the power already is caused by the ride the bicycle. And then I try to consider the 养乐多 how calorie have. And then I make the balance, okay, it's making sense in my life. So you should review the solution to your problem is make sense or not. Okay, so that's the table, very nice table, just summarize some idea when you meet the problem. So I will take the 5 minutes to go in details around this table. So the first step, you should problem statement, right? So we find the total weight. Please find the total weight. Okay, we need to know the total weight. So we need to have a W total. The problem statement, the total weight. And the total weight, we know that the tank, this is a tank, and the container tank involve the nitrogen here. So we have a nitrogen, and we only know the nitrogen, the volumes is the 17 ft cubic. And we know the nitrogen is pressurized to the 500 psi absolute. The psi already interpreted before is the pound force per inch square. And I didn't tell you what the A in here. The A is mean the absolute pressure, 绝对的压力, absolute pressure. And then I only tell you what the tank. Here, you can see the tank itself weighs the 50 pound force. So I know the W tank is the 50 pound force. And the temperature right now, the T is the 20 degree. And please work with the SI units. Please work the SI units. So the problem I statement. And what the key knowledge I need to statement is I need to know the total weight of the systems. But right now I only know the water tank, the tank, right? So I didn't know the weight of the nitrogen. So I will say I didn't know the weight for the nitrogen. This I didn't know. And if I know the nitrogen weight, and what's the total weight? The total weight will equal to the weight tank plus the weight nitrogen, right? So this is our problem. So first I state the problem statement, and then the second I need to define the situations. So as I mentioned, the situation, you should plot your systems, and you just write down what you already know, the physical properties, what you didn't know, and what's your assumptions. Okay, so you see the defined situation, you can actually to see there is assumption. With assumption to apply the ideal gas law, right? And then what the parameter we already know, I just write down here. And you see there is some unit conversion because our system is required you answer the questions by the SI units. So you can see there are some unit conversions already. Okay? And then why we need to apply the ideal gas law? Because if we consider the nitrogens, so if we have the equation is the ideal gas law tell us PV will equal to nRT, right? And if we have the volumes of the nitrogens, we know the pressures already, and we can check from the table to know the specific gas constant. And the questions already tell me the temperatures conditions. So only unknown parameter is the mass of the nitrogens. Okay? So that's why we should make some assumptions to satisfy, and then later we can apply the equations. And the third portion is a state goal. So that's why I put down some important thing is I need to compute the total weight. Okay? And then the next slide, I need to generate my ideas. So the idea is I didn't know the weight total, and I know the weight tank, but the weight nitrogen I didn't know. But how can I compute? If I apply the ideal gas law, I can compute the mass of the nitrogens. And then I apply the Newton's law, and then I can compute the weight of the nitrogen. So that's why we need to make the mass model and the equations. Because why I only show the two equations in this chapter? Because the final exercise, we need the Newton's law and the ideal gas law, and we can find out the final answers. Okay? So if you have the time when you go home, you can read some detail on the right-hand side. Usually the right-hand side showing here just step-by-step to tell you when you meet the problem, how can you solve in the problems and the step-by-step. If you can keep the idea and familiar with this idea, in the following class you can handle very well. Okay, so because you already set up all the equation you need and the plan, so there are some 4 steps. We make the plan, so we use the equation here. If we remember the equation, C is equal to the PV equal to nRT, right? So the equation C is trying to provide the answer for the mass. And if we remember the equation B, the B is trying to calculate the weight. So weight will equal to the n Newton nitrogens multiplied by 1 gravities. And what is the equation A? Because the equation A is compute the total weight. So you need total weight will equal to the total tank, weight tank plus the weight nitrogens. So this is the equation A. After you make the plan and you just calculate directly, so we move to the step 5. And after you calculate the final answer, it will equal to the 409 newtons for the total weight. And you can review your answers. So So we can step by step to see how can we review the answer. For the first sentence, you can see when the mass is the goal, and we can calculate the mass from the ideal gas law is the best equation to select. That means maybe you have another equation can calculate the nitrogen mass, but we suppose use the ideal gas law is the better one. And then to check the ideal gas law assumptions. So what are the ideal gas law assumptions? The ideal gas law assumption that indicates the two molecules there is no force between two molecules. But if there are some force between two molecules, how different compared to your answers? So you can see there are highlight the accuracy can reach to the 98% because the user also consider some interaction force between nitrogens and take into account and compare the final answer is with this number here. There are some 98% accuracy. And for the problem, for this problem, the weight of the gas is significant as compared to the weight of the tank. Because the weight of the tank is 222, but the nitrogen's weight is 187. So you can compare, it makes sense because the volume of the nitrogen is still large enough. So can have the very heavy weight for our systems. Okay. So that's I think the method showing here is very good example. So in the following class, when we do the exercise, we are trying to follow the step like the slide showing here. But not at all, but we just follow this rule to find the answer for our questions. 那我个人是觉得这个是很理论，但是感觉很有步骤，然后也很清楚。可是我们真的在解题的时候不可能这样子解，要不然一题要解20分钟，然后什么都要写得很清楚，那所以不太可能。不过我们要习惯这样子的方式去解决问题，就不要急。通常我们就是因为急，所以搞不清楚问题。所以其实对我来讲，最重要的是这前面3大步骤。我如果看不懂问题，我根本搞不清楚我现在要用什么参数，我也不知道我现在要怎么去画我的问题的这张系统的图，我也不知道我力的平衡要怎么做。那一旦我不知道这件事，我怎么可能有目标？目标我们当然知道，题目问我们什么，我们的目标就是那个，可是我不知道怎么解。那接下来这里才进到你的知识，跟如果你没有这些 equation 的知识，你其实不知道怎么去 make a plan。如果你没有 ideal gas law， 如果你没有 Newton's law， 那你当然不可能去处理这个问题。所以我觉得最重要的是 knowledge 是冷静下来去看这个 knowledge 是在这一块。你没有 knowledge， 你没办法 make a plan。Okay. So this is just why I write down the very important 6 steps for solving the problems. Okay. So in the following slides, two slides, I just summarize all application in different fields when you finish the class these semesters. So as you can see, there are some different fields. That's civil is our department, and our department includes the hydraulic divisions, and some our friend department is the mechanical, and also architectures. So different fields we will meet the different problem we should understand, and we should find the solution for our problem. So you can see some problem is PS goal, and embankment, some problems for hydraulic and the civil. But for the mechanicals, they are focused on different topics. This is the airplane problem, or the boat, or the turbine. So this is for the mechanical department. But the architecture, sometimes you just look at the structures, the design structures, and how response for the fluid. Okay, and in our department, the class design rule, we have many approaches for understand the fluid phenomena. But in our department, we only have 2 classes. We can try to figure out the fluid phenomena. The first one is the principle in this class. In the next semester, you will have the laboratory experiment to build a water boy and water girl next semester. And then we have some high levels for the field measurement or the numerical simulations. It's for the class is designed for the graduate student, not for the undergraduate student. So in your current stage, you should only have the principle and the laboratory experiment next semesters. Okay, and then I just remind you, start from the next week and after the weekends, holidays. Usually for our class, we will have 2-hour teachings. And then for the third class, I will highlight some quiz. And then in that time, you may have some problem, you can raise your hand and I can answer you the questions. And then usually we have 20 minutes for quiz. Okay, every week we will have a quiz. Okay. So any questions?